So let me use an example. Let me show you a graph. A graph I hope you're familiar with. What is this thing? It's a parabola. This would be like y equals x squared or f of x equals x squared. And let's say, just for fun, that I wanted to find out the slope right here at the red dot. Okay? And I don't really know what that location is, so I'm going to call that location x, because I don't really know what it is. And if instead of writing down y equals, I would have told you that we have another way to write that, and we call it f of x, right? We talked about that earlier. Then I know that the location of where that would hit on the y-axis, right here, that location would be called f of x.
Hoorah.
And in order to find, before we knew how to do this technique, in order to find the slope anywhere, I would have to have another point. You need 2 points to find the slope, right? y2 minus y1, blah, 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 blah. So let's say I pick another point over here. And I don't know how much farther that is away than where I already was. But if I told you that that distance from here to here was called h, then my new location, instead of being called x, would be called x plus h. And where that cross on the y-axis over here, for that point, would be called f of x plus h. Now, this whole idea, again, if you remember what the slope formula was, slope equals y2 minus y1 over x2 minus x1. But we can replace the y2 and the y1 with the second f of x thing minus the first f of x thing, blah, blah, blah. So really what's happening is that my slope is equal to my second y value, which was f of x plus h, minus my first value, which was called f of x, so that's y2 minus y1, over my my second x value, which was x plus h, minus my first x value, which was called x. What happens to the x's on the bottom here?
Cancel.
They cancel out. So I have f of x plus h minus f of x all over h.
Yeah.
And why am I showing you that? Because if you look at this picture, you don't want the slope in between these 2 points. You want the slope where the red dot is. But if I shrunk down the pink distance called h to nothingness, this line would be the tangent line right there. And so that's why you're taking the limit as h goes to 0, because you're shrinking the distance between the red and the blue point down to nothing, so that the blue point comes down and lands on the red one, and you have a tangent line. Using the definition of the derivative, I want the limit as h is going to 0 of f of x plus h minus f of x all over h. Notice how it doesn't change for anything. That's my derivative that I'm looking for, which is the same as slope. Thank you. Good job. Way to be on top of things.
Took it out of my mouth.
Put it back in his mouth, please. So really what I want is the limit as h is going to 0. There's an h on the bottom. And the first time when I look at the instruction and I plug in my x plus h, I will get 1 over x plus h.
Very good.
And then I'm going to do the second instruction, which says write down the function. So that's minus 1 over x.
Right.
Man, I've got fractions. In order to subtract fractions, I need a common denominator. So now I'm going to multiply the right-hand fraction, top and bottom, by x plus h. And I'm going to multiply the left-hand fraction, top and bottom, by x. As I start to simplify this stuff, I will have the limit as h is turning into 0. And in the purple, or I should maybe go with the dark blue that I started with, I have x times 1 on the top, which is x. And on the bottom, I have that denominator x times x plus h. I'm taking this very slowly so that hopefully it's not so bad. And then in the orange fraction, I see that I have a negative 1. So instead of leaving it as negative 1, I'm going to go with plus negative, because that will help me remember what to do with that distribution of the negative sign. So now I really have plus negative x, negative h on the top, all over the bottom of x times x plus h. And all of that is divided by h. And I'm just going to stop right there for a moment. Okay, so going a little bit farther, if I put it all together, here's what I see. I have the limit as h is turning into 0 or approaching 0. In the numerator, I now have, I'm going to go to a common color, I think here. I'm going to go to gray. I have x and minus x. They cancel each other out. So I have a negative h on the top. I have the common denominator of x times x plus h. And then underneath, I still have that h. So in case that's not clear, just so you know, all of this stuff is what this is, and the common denominator is what I wrote down here. This h here is really the same as h over 1. Why am I showing you that? Because when you divide fractions, you invert and multiply the denominator. What does that mean? That means I have the limit as h is turning into 0 of opposite h over x times x plus h times 1 over h. And now what I see is that my h's top and bottom can reduce. Or in other words, they're gone. Which means that I currently have the limit as h is turning into 0 of negative 1 over, that is a horrible, negative 1, sorry. X times x plus h. Now you would think since there's an h on the bottom that you couldn't plug in the 0, but the truth is you can. And you can because you're not multiplying by 0, you're just adding 0. So this 0 goes in for the h, and your general answer is that your derivative, y prime, or your slope, or whatever they ask you for, is going to be negative 1 over x squared. Or in other words, negative 1 over x squared is the derivative or slope anywhere on the original function that they gave us. Did I answer the question that they wanted?
No.
No. They asked me two specific locations. One at 1, 1, and 2 at 3, 4. The only value I care about in each of them is the x value. So the only thing I'll be looking at in each case is the 1 from the first point and the 3 from the second. If I look at those two locations, and I go down below, using my derivative, I can talk about what is my derivative, f prime, at 1. And it would be negative 1 over 1 squared, or in other words, negative 1. This is telling me that at the point 1, 1, my slope is negative 1. I could also ask for the slope or the derivative. What was the other point? 3 something. So at 3, that means I would have negative 1 over 3 squared, or in other words, my slope or derivative is negative 1/9.